let's install our electrical system.
Today we're building a bed, and underneath it, an entire electrical system. Which basically means I either end this episode with a working camper, or a very expensive smoke machine.
As I was getting ready to secure this bed structure to the wall, I remembered that I need to do the chassis ground first, because it requires me to remove a couple of the wall panels. So let's take care of that first, and then we secure all of this and start doing the electrical system, because I need to do that first. Oh yeah, I'm gonna fall. Now that the ground is done, we can continue with the bed structure and attaching it to the wall, the floor, and also adding some extra supports so it's a little bit more sturdy. Now that we have the structure done and these shelves cut to dimension, we need to figure out the puzzle of how these electrical components are gonna sit. In my system, I'm gonna have the things that I need access to the most over here on the shelves, like the switches and fuses and the breaker panels, and then the things that I need access to the least, like the inverter and the battery, are gonna be down underneath, as well as all of the cables that are gonna be connecting the things. Still accessible, but a little bit more out of sight. So now let's do this puzzle and cut some holes for the cables to go through cleanly. I'm starting by dealing with the thicker cable, because that one is definitely the hardest to manage. But we only have a few more connections to do. On the positive side, we need to connect the fuse to the positive here on the battery. On the negative side, we need to connect the negative side to the shunt right here. And then it's just from the distributor to the inverter, and from the distributor to the ground, which is took care not that long ago. In order to have the system balanced, it's important to have the positive and the negative run coming from the battery to be somewhat the same length.
I'm running a 200 amp hour lithium battery system paired with a 2000 watts inverter. And when you're pulling that much current, your connections have to be perfect.
Now that all the cables are cut, crimped, and heat shrinked, and we've also done all the holes in the shelves, we're gonna move on to build a little bracket to hold the batteries in place using this aluminium profile.
Next, I switch back to carpenter mode to enclose the system.
We got a bed!
But an enclosed inverter needs to breathe. So I drilled a custom ventilation grid where a couple of fans are going to be attached, and I mapped out the template for the power outlets before the final test.
Now that we have everything ready, we can start assembling and connecting everything in the electrical system, and I can tell you what everything is, how it's connected, and what it does.
To handle the power, I'm running a 200 amp hour lithium battery bank. And the first connection out of the battery is the main system switch, that big red knob, which acts as a hard disconnect for the entire van. On the negative side sits the shunt, and this is the accountant of the system. It basically measures every amp going in and out, so I know exactly what my battery percentage is. Everything routes into the links distributor. Think of this as the main terminal. It distributes power and houses the massive fuses for all the heavy equipment. For charging, I went with the Renogy 50 amp DC to DC charger with MPPT. It's a 2-in-1 combo that takes power from both the solar panels and the van's alternator while driving. Between the solar panels and the charger, there is a DC breaker, which allows me to instantly cut the solar input if I need to work on the system. Next is the big boy, the 2000 watt inverter charger. This does also two things. First, it converts our 12 volts DC power into 230 AC power, letting us run the heavy hitters like the hair fryer or the kettle. And second, it acts as our shore power gateway, meaning we can plug the van into a standard wall outlet to charge our batteries. And finally, the power is split into two distribution panels. An AC breaker panel for the 230 wall outlets, and a 12 volt fuse box. In that 12 volt box runs all of the daily essentials like the puck lights, the water pump, the roof fan. Every single circuit gets its own fuse, so if something fails, it's isolated and easy to fix.
Apart from putting all the fuses in, the only thing that's not connected still is the fans for the temperature regulator. They're going to be used to cool down all of this electrical section. So those are attached to the piece of wood that goes here at the end. So let's do that now. Now comes the moment of truth where I need to turn it on and hopefully everything works. Not everything, because I only connected 2 things. So hopefully the battery monitor turns on, and then this temperature regulator should also turn on. So fingers crossed. Yay! On. I need to change that to the correct battery. This thing is complaining because it doesn't have the temperature. It's 23 degrees in here. Not too bad. It's working! Ah! It's working, but I'm still nervous. Ooh, let's turn on the van to see if it actually charges this.
It's working. It's charging.
A few seconds for you, a few weeks for me. For the past 3.5 weeks, I was road tripping the west coast of the United States, and the first stop is Yosemite. But now I'm back to the van, so we need to finish this electrical system. When I left, we had the 12 volt was working and the alternator charging was working. So now we need to test the solar panels and everything to do with the inverter. We need to make sure that the AC sockets are working and the shore power is working. And we're gonna start by testing the inverter, just because everything is here and we don't have to go up on the roof to deal with the solar panels. Now that the fuse is on, we turn this back on. We turn the inverter on. Okay. And now we need to configure it to use lithium batteries. Okay, it looks like the battery is powering the inverter. Now let's plug in something to see if it's actually working. For the moment of truth. Power! More power, baby! So now let's test shore power. I just need to connect this adapter to the plug that I installed right here. And then plug it to the wall. Let's go check if it's actually doing anything. Okay. Input 230 volts, charging the battery. It's working. Only thing missing, solar panels. Now that we have everything wired, we put the inline fuse on the positive line. Positive to positive, negative to negative. And now we put it in the sun. Now that the solar panel is connected, I just need to turn this on and turn the solar disconnect on to see if everything works. Now the light should turn on here. Woo! And according to this, we're getting 5.2 amps, which is actually pretty good. It's pretty sunny outside, so it makes sense that we're getting almost the max we can get from this panel. Woo! Everything's working. I'm so excited. Now that I know that everything in this system is working and nice, I'm gonna add a few more extra supports on the bed and then add the lids so that I can sleep on top of them. And then I can open it with ease. We're close. We're so close. Now that the bed is finished and we know the electrical system's working, we can move on to the rest of the cabinets. But first, we're gonna take a nap. So thanks for watching, and I'll see you in the next video. Bye! Don't forget to like and subscribe.
Now they have taken AC and DC, we need to... Now that we have the... Now that everything is ready...
At the end of the system... Blah, blah, blah. Now that I know everything in the...